Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from group 7. We'll be explaining about the implementation of optimization function with two independent variables by group 7. The group 7 members, me, Aria, Wiraja, and HAMIDAH. The first is material about a company that produces two kind of product. Companies are usually in the production using one input to produce two or more products. Example, cooking oil company. Input coconut, output cooking oil and coconut cake. So the function is kx equal f bracket kx multiple py and kx equal fpx multiple py. Kx is product x requested, ky product number of product y requested, and px about the price of product x, and py price of product y. Next, then the total revenue is tr total equal trx plus try equal px kx plus py qy. And if the joint cost is tc equal f kx multiple qy, then the profit p equal trx plus try minus tc, or p px kx plus py qy minus f kx qy. For the maximum profit, the first partial derivative is carried out on the variable kx and qy in the previous equation equated with 0. Delta p per delta kx equals 0 and delta p per delta ky equals 0. The second condition is to look for the values of the second direct partial derivative and the second cross derivative, then make determinants or d. Delta power of p power of 2p per delta power of 2 delta power of 2p power per delta key power of 2y, delta 2 delta power of 2p per delta kx delta ky, and delta 2 delta power of 2 p per delta kx delta ky. So the d is delta power of 2p per delta key 2 power 2x. So this one is m, and delta power of 2p per delta kx ky is same to, so the cross. So equal delta power of 2p per delta key power of 2x, delta power of 2p per delta key power of 2y, minus delta power of 2p per delta kx per ky power of 2. Furthermore, the result of the determinant must be greater than 0. So d must greater than 0. And the value of partial derivative of the two direct correspondents must be less than 0 for the both. So delta power of 2 p per delta key power of 2x equal smallest atau less than 0, and delta 2p per delta key 2 power of 2y equal less than 0. Proper example. If the demand function for product x and y is respectively px equals 66 minus 3 kx and py equal 40 minus 5 ky. So we can make this one is 1.2, and the function joint cost tc equal q2 plus 2 key x ky plus key x2 key power of 2y. Determine the amount of price and maximize profit and look for the maximum profit. This question. So answer step 1. P equal px kx plus pa py ky minus f kx ky. So p equal px kx plus py ka minus tc. So we can equate the data. So 36 minus 3 kx brackets kx plus, because the kx we don't know what kx, so what is only px, and plus 40 minus 5 kx ky brackets minus key power of 2x plus 2, so 2 kx ky plus kx to kx power 2 y. So this is uh, formulation. So see 36 kx minus kx 2y plus 40 kx minus 5 kx power of 2y minus kx key power of 2x ky minus key t 3 kx power of 2y, and we must minus and plus same variable. So the result is 36 kx plus 40 ky minus 4 key power of 2x minus 2 kx ky minus 8 key power of 2y. So we can name is 1.3. So step 2, P double delta P per delta Kx minus 3 36 minus 8 Kx minus 2 Ky equals 0. Delta P per delta Ky equal 40 minus 2 Kx minus 16 Ky equals 0. We can name this 1.4 and 1.5. Step 3. So we can include the uh, 1.4 is this and 1.5 is. So we must sum the variable. So multiply 1 multiply 4 equal no equal 0 0. We can result minus 1. So this because the multiple 1 same, and 40 multiple 4 160 minus 8 kx minus 64 ky equal 0. So the result is minus 125 plus 0 plus 22, sorry, 62 ky and equal 0. 62 ky equal 125 and qi equal to 125 per 62. This result is 2. Substitution the value of qi in equal to in equation 1.5. So qi we substitution to the 1.5 is what. So we can get the kx equal 4. Furthermore, the value of kx and ky obtained and substituted by equation 1.2. You can see 1.2. Okay, 1.2. Okay. Then it's obtained px equal 36 minus 12 equal 35. Py 40 minus 10 equals 30. For the maximum profit, we must test the step with the second partial derivative test. So delta power of 2p equal delta key power of 2x equal minus 8. So the y is minus 60, and but the kx and px delta is minus 2. So x 60 minus 2 minus 2. So you can input in this one formula is uh, this one formula this one. So minus 8 multiple minus 60 minus minus 2 4 of 2 1000 sorry 128 minus 4 equal 124. So bigger than 0. Sin determinant value is greater than 0. So the determinant is greater than 0 or bigger than 0. The second partial derivative of profit delta on the key x and key y both are less than 0. It means that the maximum profit is key x equal 4, key y equal 2, px equal 25 as 34, and py equal 36. Sorry, 30. Furthermore, the maximum profit obtained by the company from equation 1.3 P max or maximum profit 36 multiple 4 plus 40 multiple 2 minus 4 multiple 4 minus 2 multiple 4 multiple 2 minus 8 multiple 2, and the result is 112. So the conclusion, the company must sell 4 units of the product X at the price of 24. The product Y, company sell 2 units at the price 30 in order to get maximum profit 112. So next is about price discrimination. Price discrimination can be done by a company if the company must have market power. The company know well the condition of the demand curve for their products or their elasticity of demand of their products in different conditions of the curve for each market. The company must be able to prevent result. Suppose to the company face to the free market, we name market A and market B. Then the function of the total revenue from market A and B respectively TR or total revenue A equal F GA and TRB equal G uh, GQB. And the total cost function of the two products total cost or TC equal FTA multiple KB. For the profit, P total revenue or TR A plus TRB minus TC, or P equal PA plus PB KB minus FTA multiple KB. So about the maximum profit if eligible, one, the first partial derivative of the key A variable and key B variable in question 1.6 is 1.6, then equals to 0. Delta P per delta key A equals 0, and delta power of 2P per delta key power of 2B smaller than 0. Looking for the value direct second derivative, partial derivative, and the second cross partial derivatives, then the determinant is made D. Delta 2P per delta key power of 2A, delta power of 2P per delta key power of 2B, delta power of 2P per delta key A, delta key B. So this formula delta 2P per delta key A same, and delta power of 2 key per delta key A key B same cross. So this result the formula delta power of 2P per delta key power of 2A, delta power of 2P per delta key power of 2B, delta key power of 2P per delta key A, delta key B. So determinant must bigger than 0, and the value of the second partial derivative must be less than 0 both times. So the delta power of 2p per delta key power of 2a smaller than 0, and the delta power of 2p per delta key power of 2b smaller than 0. Okay, for the problem example will be explained by Hamidah. And thank you.
Okay, I will explain a sample of price discrimination. If a monopoly says the demand function is PA is HG minus 5TA and PB is 180 minus 20 kp, and the total cost function if CC is 50 plus 20 bracket key A plus key B. Look for the maximum profit from the monopoly combination. Our total is this is the formula is GRA plus 3RB 3 total, and the total is PA key A plus PB key B. Total is 80 minus 5 kA multiply kA plus 180 minus 20 kb multiply kb is 80 kA minus 5 k square A plus 180 kb minus 20 k square B. C is PR total minus BC, and then C is HDKA minus 5K square A plus 180 KB minus 20 K square B minus 50 plus 20 bracket KA plus KB. Delta P divided delta KA is 80 minus 10 KA minus 20 is 0, and the calculation 10 KA is 80 minus 20, and then KA is 60 divided 10 is 6. The next is delta C divided delta CV is 180 minus 40 KB minus 20 is 0, and this is the calculation is 180 minus 40 KB minus 20 is 0, and then 180 minus 40 KB is 20. 40 KB is 80 minus 120, and then 40 KB is 60, and 60 divided 40 is 4. Then substitute the value of KA is 6 and KB is 4 into the demand function PA 80 minus 4 KA, and PB is 180 minus 20 KB, so that we get PA is 50 and PB is 100. To determine the maximum profit, we must test with the second partial derivative test. Then from a determinant, the result is this, Just like key square A is minus 10, just like key square B is minus 40, just like key A multiplied just like key B is 0, and this is the determinant. The result is 400 greater than 0, because the determinant value is greater than 0, and the second partial derivative of profit against P8 and P8B are both smaller than 0. It means that the maximum profit in P8 is 6, P8B is 4, P8 is 50, and P8B is 100. Furthermore, the maximum profit is obtained P much is 80 multiplied 6, 5 multiplied 6 multiplied 2 plus 180 multiplied 4 minus 20 multiplied 4 and 2 minus 50 plus 20 and bracket 6 plus 4. Then 480 minus 180 plus 720 minus 320 minus 700 is 0. Conclusion: the company must sell its product in market A at a price of 50 rupees, and the result is 6 units, while in market B the price is 100 rupees and a total of 4 units in order to get a maximum profit of 450 rupees. Again, the next is maximizing profit using two inputs. Suppose a firm uses two kinds of inputs, namely capital T and labor O, and produces a single product T. Then its production function is key is A key point O. In poor competition, firms cannot determine input prices or output prices. Suppose the input prices of key and O are R and W, and the output price of key is P. Then the profit function is this. Because key is F, key point O, then the profit equation can be rewritten as this. To maximize profit, if it meets the first required conditions, namely the first partial derivative of variable key and variable L in the equation, then equates to 0, then the result is this. And the second sufficient condition is to find the values of the second partial derivative and the second first partial derivative, then make the determinant 3, then the result is like this, and this is the determinant formula. Furthermore, saying the result of the determinant for u must be greater than 0, and the value of the second partial derivative must be smaller than both 0. Example: suppose the production function is 16 key is 60 minus 2 minus 5, 2 minus 4, L minus 4 multiplied 2, and the prices of the input and L are 8 and 4 respectively, and the output is 16. What is the maximum profit? Okay, completion. P is the formula P key minus R key minus WO is, and then we input the data 16 key minus 8 key minus 4L is and then 60 minus 2 key minus 5 multiplied 2 minus 4 bracket O minus 4 multiplied 2 minus 8 key and 4L. Delta V divided delta is minus 4 key minus 5 minus 8 is 0, and the calculation minus key equals 12 is 0, and then key is 3. And the next is delta V divided delta L is minus 8L minus 4 is 0 minus 8L plus 28 is 0, L is 3.5. To access maximum profit, we must test with the second partial derivative test, then form a determinant. The result is this: delta T square is minus 4, delta O square is minus X, and then delta T multiplied delta O is 0. And this is the determinant. The result is 32 greater than 0, because the determinant value is greater than 0, and the second partial derivative of profit to K and O are both smaller than 0. It means that the maximum profit at T is 3 and L is 3.5. Furthermore, the maximum profit is obtained P max 60 minus 2 bracket 3 minus 4 bracket 2 minus 4 bracket 3 minus 3.5 minus 4 bracket 2 minus x multiplied 3 minus 4 multiplied 3.5 is 13. Okay, in conclusion, companies in producing one kind of good must use 3 units of capital input key, and 3.5 is 4 units of labor input O in order to obtain a maximum profit of either 450. Okay, thank you guys for your attention, and wassalamualaikum warahmatullahi wabarakatuh.